So today we're going to have a look at angles between lines in both 2 dimensions and 3 dimensions. So previously we've looked at the angle between lines in 2 dimensions. In 3 dimensions we talk about the acute angle between 2 lines. So what I mean by that is if we've got 2 lines, we'll call that line 1, and we've got line 2. We talk about this angle here, theta, the acute angle, because we've got another angle here. We know these two are the opposite, so they're the same, but we talk about the acute one, this smallest angle between those 2 lines. So the way we work that out is this is equal to so it's quite similar to the 2D one. So cosine theta equals the length of vector b1 dot vector b2 over the length of b1 times the length of b2. All right, so yeah, that's the equation, and we'll have a practice with that a little bit later. So there's a couple of important cases to consider. So if we've got 2 lines, first line is R1, and that's equal to A1, the starting point, plus lambda of B1, the direction vector. So this is the way where it's moving. And you've also got R2 equals A2 plus lambda B2. So 2 lines. Now, if those 2 lines are parallel, meaning running forever next to each other, never crossing, never separating, if B1 is equal to k lots of B2, so some scalar lots of B2. And if that's the case, we write R1, then these 2 vertical lines for parallel with R2. So that's parallel. The other one is perpendicular. So R1 and R2 are perpendicular if the dot product of B1 and B2 equals 0. So if the dot product is 0, and the reason for that is the dot product's on the top line there. If the dot product is 0, we write R1 is perpendicular to R2. Okay, so those are just 2 unique cases. So what we've got here is we've been asked to find the angles between lines L1 and L2. So L1 is going through this point here to -1, 4, and it's got the direction vector, remember that, -3, 1, and 2. And the other one we've written in our Cartesian form. Okay, so we want to find the angles between these lines. So what we want to do is we know that the formula is cosine of theta equals b1 dot product with b2 over b1 multiplied by b2. So we need to find b1 and b2, and those are going to be our direction vectors. Okay, so I'm going to call this line 2 actually. So for line 1, our direction vector is 3, -3, 1, and 2. And for our line 2, we're going to get, before in our Cartesian form, we always had x written at the front. So we need to multiply this one by -1. And we know the bottom line is our direction vector. So if we multiply that whole thing by -1, this is going to become -3. This one here is already good, so we can write 1. And this one here has got 2 at the bottom, so we multiply that by -1 again, and we get -2. All right, so there are our 2 lines. Now, we just saw that if our L1 is equal to some scalar multiple of our L2, so if R1 and R2 are perpendicular, sorry, not that one, R1 and R2 are parallel if B1 equals KB2. All right, so if you have a look at what we've got, you got 3 and -3, so -3, -3, 1 and 1. If you multiply those both by 1, they're equal. 2 and -2, so those don't quite work. But if that was a -2 and a -2, we could say straight off the bat that these are parallel. they're not, so we can work them out. So although I label these L1 and L2, we're going to treat them as B1 and B2 for this equation. So the dot product between those two is -3, 1, 2. Dot product with -3, 1, -2. And that's going to be over the length of 3, 1, 2, dot with -3, the length of -3, 1, +2. No, -2 for that one. All right, so if we take the dot product of the top row, we do -3 times -3 is 9, plus 1 times 1 is 1, plus 2 times -2 is -4. And we're going to divide that by the length of this one, which is the square root of 3 squared plus 2 squared plus, that's -3 squared, plus 2 squared plus 1 squared. And the other one is going to be the square root of -3 squared plus 1 squared plus -2 squared. And these are actually going to be the same. So we're going to get, this should be the positive. 9 plus 1 is 10, take 4 is 6, divided by 3 squared, 9, plus 2 squared, 4, 13, plus 1, square root of 14. And the same on this side, that's going to be square root of 14 as well, which is actually equal to 6 over 14. All right, so therefore theta, because this was equal to cosine theta, therefore theta equals the inverse cosine of 6 over 14. And we can just put that into our calculator. All right, and that equals 71.8 degrees. All right, and that's how you find the angle between those two lines. Thank you.